I am Dr. Joseph Granum, PhD candidate at the University of Tartu. The title of my presentation is Towards a Theoretical Model for Enhancing Spatial Thinking and Science Performance. Progress and Insights from a Digital 3D Learning Tool. My supervisors are Professors Seaman and Tam. So the background. Spatial thinking is essential to success in anatomy, by extension, or clinical sciences, and the wider STEM field. We know the human body is a 3D object. However, our teaching primarily focuses on 2D learning materials. So our students struggle with the conversion of 2D to 3D. As a result, they have high cognitive load when learning, and so they have poor academic performance in the anatomical sciences. We are also aware that there are emerging digital 3D tools that show promise in terms of assisting with this, but there is a lack of unified theoretical framework or high quality empirical studies to guide us. So the problem that we have highlighted in terms of our statement is a validated model linking spatial ability, cognitive load, and academic performance is lacking, resulting in digital 3D tools that are often under-theorized or poorly evaluated. This highlights the importance of instructional design based on evidence and robust learning theory. So we have three theories forming our foundation. Cognitive load theory, which has to do more with a reduction of extraneous load, all the additional stuff we put in our multimedia presentations that's not related to learning, and optimize the germane load, which allows for the learning to take place. Then we have cognitive theory of multimedia learning by Richard Meyer, in which we're looking at the approach that we learn by two channels. We listen, so auditory, and we see, which is visual. And the aim is not to flood both channels at once, but to focus on one channel, in which case we're looking at visual cues. And then there is visual spatial working memory coming from cognitive architecture, which has to do in understanding what happens when we see visualizations of the material we're learning. In terms of this case, mental rotation supporting learning, initially in the short term as the concept is being taught, and moving it into long-term memory, which is needed as we train and move into our physical environment of clinical sciences. So we pose 4 research questions. What does the literature suggest on the design and impact of digital 3D versus 2D in comparative studies in anatomy education? How does this design of a digital dynamic 3D model impact mental workload and performance? What strategies are used by our students? Our third question. And then the fourth question has to do with an artifact. What would we have as an instructional design guidance for the use of 3D in anatomy education? So our research approach first was to check the literature. We did a systematic literature review. Then we decided on a design-based research methodology, and this is because we wanted all the stakeholders to be involved. We used mixed methods, both qualitative and quantitative arms. We went for a prototype that was dynamic, so showed movement. And we validated our data using NASA TLX, and analyzed the spatial anatomy test using multidimensional item response theory, pre and post test data, as well as interviews. Progress and insights to date. We have 1 currently accepted article, journal-based, and we have 3 published conference articles starting in 2021 with ICULT, IEEE, which is the Design and Evaluation Study, which is a pilot study. And then in 2024, ICA IEEE, we had both the SLR being published in the comparative study for 2D versus 3D, as well as the DBR, the design-based research approach, and how far we are in terms of our cycles and what we have. Insights from our preliminary findings suggest that 3D group seems to be doing better. And coming from the NASA TLX, we note that less frustration seems to be a part of the workload from the 3D group. So our design rooted in cognitive load theory, as well as understanding the visual spatial working memory, seems to be yielding fruit at this stage in our trends that we are noting. Our next step is to refine the model through main study across different contexts within the anatomical sphere, and we collect data from students within Estonia, Lithuania and the Baltics, and Jamaica, which is my home base. The Plan is also to extend this design, which is 3D based using monitors, into 3D immersive learning in anatomy education as an extension of the project. So our contribution going forward, we're looking at a theory-driven, evidence-backed instructional design framework for 3D learning tools in the anatomical sciences, which later can then be applied to the wider field of STEM. Thank you. Looking forward to your feedback and collaboration from iLearn. Please note references and the articles are available. Upon request, you can use the contact here at the end of the slide.